Hello, here's your video on section 9.5, the binomial theorem. So after you're done watching this video, you should be able to evaluate factorials and combinations, expand using the binomial theorem, and find specific terms using the binomial theorem. So the first thing we're looking at is factorials and combinations. So the factorial is that little exclamation point, and basically what that means is you're starting with that number and then multiplying it by one less than that number and then multiplying it by one less than that number. So for example, if you're looking at 4 factorial is the same thing as 4 times 3 times 2 times 1. So you're starting with that number going all the way to 1 and then multiplying. So 4 times 3 times 2 times 1 is 24. For a combination, so combinations can be written several different ways. You read it as n choose k, so you can see it written like this, where it's parentheses with n on top of the k. You also might see it written in that notation where you have the c for combination, and then n and k in parentheses. Or you might see it like this, where you have the n and the k on opposite sides of the c. These three things are just three different ways to denote the combination. There's a formula for the combination, it's this right here, and it deals with factorials. So what we're doing for the example is we're trying to find 7 choose 5, because it's n choose k, n is 7, 5 is k. So my n is 7, so I have 7 factorial over 7 minus 5 factorial. Oh, I should close out that parenthesis. Times k factorial. So I have 7 factorial over 2 factorial times 5 factorial. Now 7 factorial, I'm going to go ahead and expand a little bit. That's 7 times 6 times 5 factorial. Now if you'll notice, I stopped at 5 factorial, and the reason why I did that was because these 5 factorials are going to cancel. So that just leaves me with 7 times 6, which is 42, over 2 factorial, which is 2 times 1, so 42 over 2, which is 21. Now on your calculator can actually do combinations, and this calculator trick will be very, very useful once we get to the binomial theorem. So what you're going to do is you are going to hit math. You're going to move over to PRB. And you're going to select number 3 where it says NCR. Now when you select that, it puts the ANS in front of your NCR. Move over to the left and make that a 7. And then go back to the right and type in the 5. So in your calculator, you should be looking at something like this. And then go ahead and hit enter. And it gives you 21. So just a little calculator shortcut. You don't really have to do combinations by hand, but I figured I would show you how that formula works. We're mostly going to be doing combinations in the calculator. So the next thing we're looking at is called the binomial theorem, and when I show you the next slide, it's probably going to look really overwhelming, but don't freak out because it's not that bad. There it is. So the binomial theorem is a theorem that allows us to expand binomials. So I have that a plus b to the nth power. So that's a binomial that I'm trying to raise to a particular power. So I can do a plus b squared, a plus b cubed, a plus b to the 4th, a plus b to the 5th, and so forth. Now this I actually already expanded. But let's say I wanted to do a plus b to the 10th power. What I can do is I can use the binomial expansion. And this right here, this entire formula, which again looks overwhelming, is the binomial theorem. And if you'll notice, with each term, we're looking at combinations, which is why that shortcut on the calculator with your combinations will be very, very helpful. So this formula looks intimidating, but it'll make more sense once we actually work through a problem. So I'm not really going to explain all of these little pieces right now. I'll just kind of work through the next example, and then hopefully it'll make sense. Okay, so what you're looking at is you're looking at raising x plus 4 to the 6th power. This 6 right here represents your n. The formula of the binomial expansion uses a and b, so this x is your a and this 4 is your b. So when I'm taking x plus 4 and raising it to the 6th power, the first thing that I'm going to do is the first combination, which is n choose 0. So that's 6 choose 0. And then I'm going to take my a and raise it to the nth power. So a is x, so I'm going to take x and raise it to the 6th power. For my second term, it's n choose 1. So I have 6 choose 1, and then I'm going to take x and raise it to the n minus 1 power. So my exponents for my x's are going to descend. So this is going to be x to the 5th. And now I'm actually going to incorporate b, which is 4, and I'm going to raise that to the 1st power. For my third term, I'm going to do 6 choose 2, and it's going to be x to the 4th, and then 4 to the 2nd. Now there are several patterns that you'll kind of notice with the binomial theorem, and I'll talk about those patterns once I'm done fully expanding. For the next term, it's 6 choose 3, x to the 3rd, 4 to the 3rd. So if you'll notice, the exponents on the x's are descending. So it was 6, 5, 4, 3. And then for my 4's, I didn't have a 4 with the first term, but with the second term, it was 4 to the 1st. So it's 1, 2, 3 for those exponents. I'm going to keep going. So that's 6 choose 4, x to the 2nd, 4 to the 4th, plus 6 choose 5, x to the 1st, 4 to the 5th, and then finally, and I ran out of space. I was hoping I was writing small enough that I wouldn't run out of space. But finally, I have 6 choose 6, and then for my next one, it would be x to the 0, so there is no x because that would just be 1. And then 4 to the 6th. So let's talk about a few of the patterns here. So if you'll notice with the combinations, all of these top numbers are n, so whatever that power is. So all of them are 6's. Get rid of those lines. Okay. And then your exponents for your x's were descending. So you had 6, 5, 4, 3, 2, 1, and then you didn't have an x. For your other term, that b, the 4, your exponents were increasing. So you didn't have a 4 over here, but then it was 4 to the 1st, 2nd, 3rd, 4th. So it was 1, 2, 3, 4, 5, all the way up to 6. And we stop at 6 because your n is 6. Another thing you might notice with your powers for the 4, these two numbers are exactly the same. So your exponents for the second term correspond to that bottom number of the combination. Now these patterns will be very, very important once we get to the second half of your notes, which is kind of why I'm talking about it right now. Okay, so this was just setting up the binomial expansion. We do still need to simplify it. So I'm going to use my calculator and do 6 choose 0. So I'm going to type in my 6 first. It's math, moving over to PRB, option number 3. So I have 6 choose 0, which is 1. So my first term is 1x to the 6th. Plus, I'm going to do 6 choose 1, which is 6x x to the 5th times 4. Plus, now I'm going to do 6 choose 2, which is 15, x to the 4th, and 4 squared is 16, plus 6 choose 3, which is 20, x cubed, and then 4 cubed is 64, plus 6 choose 4, which is 15, x squared, and then 4 to the 4th, use my calculator for that one, is 256, plus 6 choose 5, which is 6, and then x times 4 to the 5th, which is 1024, plus 6 choose 6, which is 1, times 4 to the 6th, which is 4096. And last but not least, I just need to simplify all of those terms. So my final answer is x to the 6th plus 24 x to the 5th plus 240 x to the 4th plus 20 times 64, oops, 20 times 64 is 1280 x cubed plus 15 times 256 is 3,840. You guys can hear my dogs barking, they're going a little crazy. Where was I? So 6 times 1024 is 6,144x plus 1 times, oh, I don't need a calculator for that. And this right here is your expansion. I know the process is very, very long, but that's because I gave you something being raised to the 6th power. I don't think I would ever give you something that large on an assessment, but it's good practice. All right, let's do another one. So this one we're raising to the 5th power. So I'm going to start with 5 choose 0. And then I'm going to take my first term and raise it to the 5th power, and then I'm not even going to use my second term. Plus, and then I'm going to do 5 choose 1. My first term, that exponent's going to start to descend. My second term, my exponent's going to start to increase. Plus 5 choose 2, and then that's 2x to the 3rd negative y squared plus 5 choose 3, that's 2x squared negative y cubed, oh, ran out of space, plus 5 choose 4, and then that's 2x to the 1st negative y to the 4th, and then finally 5 choose 5. Don't have my 2x anymore, but I'll have negative y to the 5th. So again, if you look at your exponents on your 2x, it was 5, 4, 3, 2, 1, and then no 2x at the end. And then for my negative y, I didn't have a negative y, and then my exponent went 1, 2, 3, 4, and 5. Okay, so let's start simplifying this. Now I do want to start to make this go a little faster with the calculators. So when I'm calculating this in the calculator, here's exactly what I'm typing in. I'm going to have my parenthesis, and that's going to be the 5 NCR with the 0. And then I'm also going to do 2 to the 5th at the same time. That way I don't have to simplify towards the end. So for this first term, so I have 5, I'm going to hit math, move over to PRB. So 5 choose 0 times 2 to the 5th. And that gives me 32 x to the 5th. for my first term. For my second term, here's what I'm plugging into the calculator. I'm going to do 5 NCR1, and then I'm going to do 2 to the 4th, and then I'm going to do -1 to the 1st. Okay, I want to type in everything at once. That way I don't necessarily have to simplify as we go. So let's see. So I have 5 choose 1. Now this is 2 to the 4th, and then -1 to the 1st. And that gives me -80, so I'm going to change that plus to a minus. Oops. So that's -80, and that's x to the 4th, y. So what I'm plugging into the calculator is just the numbers. So for my next term, it's 5 choose 2, and then that's 2 to the 3rd, and -1 to the 2nd. And that gives me +80, so that's plus 80, and your x was being cubed, your y was being squared. And then for the next term, it's 5 choose 3. And what I'm doing in the calculator is I'm just editing what I already had typed in. That way I don't have to retype everything. Makes it go by a little faster. So my next one ended up being a -40 when I plugged it into the calculator. So -40, and that's x squared, y cubed, plus, now I'm doing 5 choose 4, and then that's 2 to the 1st, -1 to the 4th, which is 10. So that's 10x, y to the 4th. And then finally, I'm doing 5 choose 5. I don't have my 2 anymore, so I'm going to get rid of that. And then, oh shoot, calculator trouble's over here. And then I'm taking -1 and raising it to the 5th power, which is just -1. I don't know why I needed a calculator for that. But that's -1 y to the 5th power. And this is your fully expanded using the binomial theorem. So this lesson is actually separated into 2 days. So the first day is expanding using the binomial theorem, and the second day is finding specific terms. I'm going to go ahead and continue with the video and just do it all at once, but you're more than welcome to stop the video and then just pick this up tomorrow for day 2. Okay. So day 2 is finding specific terms, and when you're finding specific terms, it is very, very important that you recognize what the patterns are. So it's finding the specified nth term of the expansion of the binomial. So in this case, I'm taking 1/3 x plus y squared and raising it to the 5th power. And what I want to do is I want to find my 4th term, because that's what n is. Now what I can do is I can expand the entire thing and find the 4th term that way, or if I could recognize some of the patterns with the binomial theorem, I can just find that specific term. So let me go back to the previous problem. Now let's say for this one I'm looking at this 4th term. So here's my first term, first, second, third, 4th term. Okay, so for my 4th term, let's try to look at some patterns. And what I'm going to look at is I'm going to look at this bottom number of the combination. Okay, so for my 4th term, the bottom number of the combination was a 3. So it's 1 less than n. So I'm going to use that to set up my next problem. So I can set up the combination, and my bottom number is going to be 1 less than n, so that's going to be 3. Okay. Now, your top number is always whatever this exponent is, so that's 5. So this combination is 5 choose 3. Now, this bottom number, which we talked about earlier, let me go back to this problem. This bottom number always corresponds to the exponent of the second term. Okay, so if you'll notice, all of these exponents are the same. So that means for my second term, which is y squared, that's going to be raised to the third power. Now another pattern that we need to recognize is the exponent for the first term. And if you'll notice with the exponent for the first term, your two exponents should add together to equal whatever that power is. So I have 3 plus 2 is 5, 2 plus 3 is 5, 4 plus 1 is 5, and so forth. So that means my exponent for my first term, for that 1/3 x, that exponent is going to be a 2, because these two exponents should add up to this top number. I know it's a lot to process, but once you recognize the patterns, it's not so bad. So again, I'm going to plug in everything into my calculator at once. So here's what I'm typing into my calculator. It's 5, and then NCR with the 3. I'm going to take my 1/3 and raise it to the second power. And then my y doesn't have a coefficient, so I don't have a number that I need to actually raise to the third power. But I'm going to start typing, so I have 5, NCR with the 3, and then 1/3 to the second power. That gives me 10/9, and then my x is being raised to the second power, so that's x squared, and then y to the 6th. And that is your answer. Alright, let's do another one. So it says find the term that contains y to the 6th when you expand x squared minus 2y to the 3rd to the 5th power. Okay, so when I'm trying to find a y to the 6th, so that means my second term, negative 2y cubed, has to be raised to some power to get y to the 6th. Well, what do I have to raise a cube to get y to the 6th? That's going to be to the second power. So this negative 2y cubed has to be raised to the second power, which means for my combination, my bottom number is a 2. And my top number always corresponds to the exponent on the outside that you're raising the whole thing to, so that's a 5. So if my second term is being raised to the second power, that means my first term has to be raised to the third power. Because once again, these two exponents, when I add them together, has to equal that. Alright, so here's what I'm putting in my calculator. It's 5 NCR2, and then negative 2 to the second power. So 5 choose 2, negative 2 to the second power, and that gives me 40 x to the 6th, y to the 6th. So this would be the term that contains x to the 6th if you were to fully expand it out. Okay. Last one, find the coefficient a of the term in the expansion of the binomial x squared plus 3 to the 12th power. And it says a x to the 8th. So this one is very similar to the previous example. So I'm trying to find the term that has x to the 8th in it. So x to the 8th, x is my first term. So I need to figure out what is it that I need to raise x squared to get x to the 8th. Well, I need to raise it to the 4th power, because 4 times 2 gives me the 8. My top number for my combination is always equivalent to this exponent. So that's 4. And then for my second exponent, it needs to add to 4 to get 12. So that means my second exponent needs to be 8, because 8 plus 4 is 12. And since my second exponent is 8, that means the bottom of my combination is also 8. I'm going to take this and put it into my calculator. So now I'm doing 12 choose 8. And then I'm multiplying it by 3 to the 8th. Oh, it gives you a very large number, but that's okay. So that's 3, 2, 4, 7, 6, 9, 5, x to the 8th. And this particular problem was just looking for the coefficient. So there's your coefficient. All right, so that finally concludes all of your notes for the binomial theorem. I know it's a lot to process, so feel free to watch this video several times until you get it figured out.